Now that we've talked about some addressing issues, and trust me, we're going to go back to that in the section regarding specifically IP subnet addressing, from here I'd like to talk about some of the network services that we need to make TCP/IP work properly. First up would be the DHCP protocol, which is the Dynamic Host Configuration Protocol. Now, DHCP had its roots in a few other protocols prior to it. One called RARP, which is reverse ARP, would essentially request an IP address from a static server that would say, this is for this MAC address, this device gets this IP address. There was no other information there, just this MAC address to this IP address. From there, we had a bootp server, and if you look at the ports that are assigned for DHCP, you see that the two ports assigned to it are for bootp client and bootp server, which is where its roots come from. The bootp process allowed a client to get from a server not only its IP address, but other information we need, such as subnet mask and default gateway and DNS address, which we're going to talk about next. The problem with bootp is there was no lease time. It would never actually release the address in question. So that brings us to what we've currently been using for several years, which is DHCP. Now, a client makes a request. It's really a broadcast saying, hey, I'm looking for a DHCP server because I don't have any IP address information. The server, hopefully being on the same LAN, sends the message back saying, hey, I've got the information for you. It's a unicast message sent back to the client's MAC address. When the client receives that, it says, thank you, can I have an address, which is a broadcast again, in which case the server responds back and says, here you go, here's your address. So that whole process of sending information back and forth will allow a client to get the IP address information it needs for communicating on the network. Now, depending on whose DHCP server you're using, some additional features can be done on the back end for the platform in question. For instance, like Microsoft DHCP server can register the IP address with dynamic DNS and do a few extra things. And there's a lot of options within DHCP that can be turned on, not just the basics for IP, which again would be the IP address, the subnet mask, the default gateway, and the DNS server. There's a Win server option you can use in a Windows network for negotiating the net NBT, net BIOS over TCP/IP information for browsing network neighborhood. There is things like TFTP servers that can be identified. Your telephones, your Cisco IP phones, will use option 150 to identify the TFTP address of a Cisco call manager within the network, and that can be handed out via DHCP. So there's a lot of information that can be handed out, and again, we have a lease time with respect to DHCP, so that once a client disappears and is taken off the network, the server can take that address and put it back in the address pool so somebody else can grab it. Which is, again, one of the problems with bootp, as I mentioned. You'd have a consultant come in, plug into the network, do some work, and then leave, but the address would be taken out of the pool and somebody would have to manually administer the bootp server to release those addresses that had been used and then not continued their use for quite a while. So I just mentioned that one of the cornerstones of the TCP/IP suite, as far as network services, is DNS, which stands for Domain Name Service. Now, Domain Name Service allows us as humans to really use something like the Internet because we don't all want to have to remember the IP addresses of particular websites. Now, it may not be so necessarily hard to remember an IP address here or there, but remember as many as we'd have to remember would be a little bit ridiculous. That being said, just wait till we get to IPv6, and it's darn near impossible to remember an address. So DNS is, again, one of the cornerstones of what we do. If I type in www.website.com, it's going to go out and do a resolution to a particular DNS server, then responds back with the IP address of where that particular server exists. So it allows us to create a layer 3 connection, a packet from our machine to that particular website. Now, there's two important parts of this. In a few minutes, we're going to talk about the differences between TCP and UDP, but it's kind of interesting that DNS works both on the TCP side, a connection-oriented session, and a connection-less setting for DNS as well using UDP. If you have a client making a request for a website, name of a particular website, and wants an IP address resolution, that's done in a connectionless fashion using UDP. Whereas if you have two DNS databases exchanging IP address to name resolution between one database and another, that's done reliably using transmission control protocol. So you'll see that certain things, certain services, both will have an identifier to do this in a connection-oriented state and a connectionless type fashion.